Welcome everyone, and thank you for joining me today. In this presentation, we'll be exploring the system overview and concept visualization of a plumbing layout. We'll look at how the main pipe connects from the water closet, how branches are formed for lavatories, showers, and floor drains, and how vent pipes rise to the roof. We'll also go over some fundamental principles like the slope formula, which is essential for proper drainage. So let's dive into the details and see how these components work together to create an efficient plumbing system. Let's take a look at the purpose and location of the cleanouts. Generally, you'll find the main cleanout located behind the toilet, which is the WC or water closet. In addition, there are cleanouts near the floor drain and at the main collection point. Each of these cleanouts is capped, making maintenance access straightforward when needed. A key point to remember is the spacing between cleanouts. The general rule of thumb is that they should be spaced no more than 15 meters apart. For example, if you have a group of fixtures within 6 meters, then just one cleanout is sufficient for that area. You'll notice on the slide various icons: the toolbox for maintenance, the showerhead for drain access, the ruler indicating spacing, the WC for water closets, and the cap symbol for capped access points. All these elements highlight the importance of strategic placement and accessibility of cleanouts to ensure proper maintenance and efficient drainage. This concept ties into the overall goal of designing an effective and reliable plumbing system. Let's take a closer look at the floor drain and trap connection. On this slide, you can see a cross-section that illustrates how the floor drain, the gully trap, and the Y-join connect to the main drain. The traps play a vital role here because they retain a water seal, which is essential for blocking unpleasant odors from escaping into the space. A key point to remember is the water seal depth. The formula is simple. The water seal depth should be at least 50 millimeters. For example, if we have a floor drain trap that is 55 millimeters deep, that meets the requirement and is marked as white heavy checkmark OK. These details might seem small, but they are crucial for maintaining a hygienic and odor-free environment. Always check that the water seal is sufficient, as indicated by the icons here: hole for the floor drain, bricks for the trap, droplet for the water seal, and dashing away representing the vent. Understanding how these components work together helps ensure your drainage system functions properly and prevents any potential issues down the line. Let's look at how the lavatory and shower lines connect to the main WC drain. The 15-branch pipes from both the lavatory and the shower join the 100 main WC line using a 45-degree Y-connection. This Y-connection is crucial because it allows smooth merging of the waste lines, ensuring proper flow. Now, to prevent siphoning, vents are connected upstream of these junctions. Venting is essential because it equalizes pressure within the piping system, avoiding the risk of emptying traps or causing blockages. When it comes to calculating flow, remember the basic formula. Q equals A times V, where Q is the flow rate, A is the cross-sectional area, and V is the velocity of the waste. For example, with a 15 pipe, the cross-sectional area is 0.002 square meters, and if the velocity is 1 meter per second, then the flow rate is 0.002 cubic meters per second. These details are vital because they ensure our plumbing system functions efficiently and prevents issues like siphoning or blockages. The symbols here, like the SOAP for lavatory, showerhead, junction, vent, and Y-join, help us quickly identify each component in the system. So, understanding these connections and calculations keeps our plumbing design both safe and effective. Let's take a look at the vent system integration. The vertical green vent connects above the traps of all fixtures, which is essential for maintaining pressure balance throughout the system. This connection helps prevent unpleasant odors from escaping and also prevents back pressure that could disrupt proper drainage. Now, when designing these vents, there's a simple formula to follow. The vent diameter should be at least half the size of the main drain diameter. For example, if the main drain is 100 millimeters, then the vent should be at least 50 millimeters in diameter. It's important to consider the airflow, which is represented here by the dashing away symbol, and how it relates to odor control, marked by the prohibited symbol. The straight ruler indicates the importance of proper diameter sizing, while the bricks symbolizes the wall vent, and the houses illustrates the roof exit point. All these elements work together to ensure the system functions efficiently, preventing odors and balancing pressure, which ties back to our overall goal of creating a safe, effective, and odor-free plumbing system. Now, let's talk about the testing and handover process, focusing on the internal checks. First, a flood test is performed up to the FD level, using a pressure gauge on the cleanout to monitor the pressure. The inspector then verifies the slope of the pipe to ensure proper drainage, as well as checking for any leaks that could compromise the system's integrity. A key point here is the testing formula. The test pressure, P-test, is set at 1.5 times the design pressure, P-design. For example, if the design pressure is 1 bar, then the test pressure should be 1.5 bar, and this pressure must be maintained for at least 15 minutes to confirm everything is tight and secure. Throughout this process, we use symbols to keep track of the steps: a water drop for the test, a gauge for pressure monitoring, a report icon for documentation, and a quality control check to ensure everything passes. When all these steps are successfully completed, we mark the system as passed with a check mark, indicating it's ready for the next phase. This testing phase is crucial because it confirms that the system is leak-proof and correctly installed before we move on to handover. It's a key part of maintaining quality and safety standards across the project. Now, let's walk through the installation steps for the field sequence. First, we start with laying out the pipe levels. This is crucial because accurate leveling ensures proper flow and prevents future issues. Next, we move on to fixing supports, which hold the pipes securely in place and maintain the correct alignment throughout the installation process. Once the supports are in place, we assemble the 45-degree Y fittings and traps. These components are essential for directing waste flow and preventing odors from escaping. After that, we add vents and cleanouts. Vents are important for air circulation and proper drainage, while cleanouts provide easy access for maintenance. The final step is testing the system and pouring the concrete. Testing verifies that everything functions correctly before the concrete is set, ensuring a durable and leak-free installation. Now here's a quick tip. Remember the formula for the drop, which is the run multiplied by the slope. For example, if you have a run of 2.5 meters and a slope of 2%, the drop would be 50 millimeters. This calculation is key to maintaining proper drainage. Throughout this process, I like to think of the icons on the slide as a visual guide. Lay out pipe levels, fix supports, assemble fittings, add vents, and then hand over the completed system. Following these steps carefully will help ensure a smooth installation and a reliable system in the end.